What I'm doing is now, I'm in the middle of a video, so what am I doing? Up top, right? Can you see that? Okay. So ammonium is here, right? Ammonium nitrate, right? Ammonium, right? The ammonium ion and the nitrate ion, right? The bomb that blew up the Oklahoma Federal Building in 1993. Can you look that up, please? See if you can find the mass of ammonium nitrate that blew up the Federal Building in Oklahoma City, approximately 1993. Whatever. I don't even know if I have the date right. Look it up. Baslin, can you get on that for me, please? Okay. So how many of each do you need? What's the formula? Ammonium is NH4. Nitrate is NO3. Ammonium has a +1 charge. Nitrate has a -1 charge. What would be the formula? What would be the formula? Yes, E-Man.
NH4, but in brackets.
Nope, don't need brackets, because you have one of each. NH4, NO3. Okay? You'd say NH4, NO3. Yes? Ammonium nitrate. Yes?
Yeah.
Do we have the information on the Murray, I think it's the Murray Federal Building in Oklahoma City?
Yeah.
What year was it?
1995.
1995. I had the year wrong. Maybe that was the year I got married. I'm equating my marriage to a fertilizer bomb. That's not good. That's not good. Okay. Well, so it was 1995? Are you sure?
Yes.
Okay. And does it give any statistics about the size of the bomb?
Not really. But
Okay.
It said that it exploded and it damaged 16 block radius.
16 block radius. Can you imagine one bomb? The thing was horrific. 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 Many people died. It was terrible. Terrible. Little kids. I think they had a daycare center there in the Murray Federal Building. I think that was one of the things. It was terrible. Terrible, terrible, terrible. But anyway, that's what they used. They used ammonium nitrate. Okay, so a lot of these are going to be very, very, very common. Okay, magnesium sulfate. Any athletes in here? Yeah? Have you ever used Epsom salts? No, know what that is? You soak in Epsom salts? That's magnesium sulfate. +2, -2. MgSO4. Magnesium sulfate. Great for constipation. Gets the bowels flowing a little bit. Yeah? Oftentimes, magnesium is used as a laxative. Okay? Now, cyanide down here. Okay? I know they used to, I think in California gas chamber, they used to mix, wasn't it sulfuric acid and potassium cyanide? Look that up. California death chamber cyanide reaction. See what it says there. Look that up. Death chamber. The gas chamber, yeah. They call it the death chamber, I think. The gas chamber, California gas chamber, that was very famous at one time. What do you got? Anything? So while he's working on that, potassium and cyanide. What's the formula for potassium cyanide? Anybody? Jose? What do we got? KCN. Potassium cyanide. How about this? Has anybody ever heard the term, something you use at home, called bleach? Anybody heard bleach before? What's the active ingredient in bleach? What is the active ingredient in bleach? You know what it is? One chlorine and one oxygen together, one oxygen and one chlorine together. It's called hypochlorite. It's called hypochlorite. ClO, -1 charge, is called hypochlorite. And bleach is generally a salt made. You know, salt is just not sodium chloride. All these are salts. It's going to be sodium +1, hypochlorite -1. So what's the formula for sodium hypochlorite? What is the formula for sodium hypochlorite? What do you got? What is it? Anybody?
NaClO.
Z-Man, excellent. Salama, I love it. Love it, excellent. NaClO. Okay? Yes, good? How many people feel strangely comfortable so far with my explanation of nomenclature? Raise your hand. Wow, cool. That is unusual. I do this in the United States, you know. I get the same spiel in the United States. And people look at me like they're crying or something. I mean, they just look at me with these eyes like, I can't believe you want me to do this stuff, you know. But international students, it's so much easier teaching this because you have such a better ear for languages. Okay. Let me show you something about polyatomic ions. Even though it sounds like a random collection of nutty things, let me show you a few things, okay? All right? Okay. Okay. This is the number of carbons. I'm sorry, this is the number of oxygens. Okay? And these are the charges. Okay? I'm going to make up a chart. Okay? First, let me do something over here, okay? All right? I won't do Br. I won't do bromine. Is that okay? Okay. This one is, you ready? I'm just going to name this right here, okay? I'm going to name these. And then these are going to be, you'll see how they're the same, okay? This is going to be it's been a long day. Okay, so this is hypochlorite, chlorite, chlorate, perchlorate. You see that? Chlorite, hypochlorite, 1 oxygen. Chlorite, 2 oxygens. Chlorate, 3. Perchlorate, 4. What would this be? F. Hypofluorite, fluorite, fluorate, perfluorate. Iodite, hypoiodite, hypoiodite. Am I on? Am I on? Yes, I am. I'm on. Okay, good. Hypoiodite, iodite, iodate, periodate. You get that? You understand? You're sure? Yes or no? Okay. So, we're going to do one representative for -1. We'll do bromine. Okay? So bromine, O, BrO2, BrO3, BrO4. For -2, you have your choice. Sulfate or carbonate. Doesn't matter, does it? Sulfate. Let's do carbonate, okay? Carbonate. What is carbonate? First of all, you have to know what carbonate is before you can do this. So what's carbonate? Carbonate is CO3. Okay? This is bromate. So carbonate is here. So this would be CO4, right? CO2, and this would be CO, right? All -2 charges, correct? Can I get rid of this here now? Can I get rid of this?
No.
It's on film, guys. As I asked you, right? Sorry. All right, it's this one. Let's take phosphate. What's phosphate? Phosphate is -3. Phosphate is PO4, right? That's phosphate. Right? So that's PO3, PO2, PO5. Let's do one more. We're going to make another column for -2. Sulfate is what? Sulfate is here with phosphate. This is sulfate. This is sulfite. This is, see that? See, so all you have to do is know the system and then just memorize something. This is what I memorized as a kid. I memorized the 8s. I memorized the 8s. Okay? Then you just work up and down. Easy? Easy? Hypobromite, hypocarbonite, hypophosphite, hyposulfite, bromite, carbonite, phosphite, sulfite, bromate, carbonate, phosphate, sulfate. Perbromate, percarbonate, perphosphate, persulfate. You get it? But you don't have to memorize anything. I will give you, every time you take a quiz or a test, you will have at your disposal a clean polyatomic ion sheet. Do you get it? You understand? And you will have quizzes, multiple quizzes every single day between now and February. Yeah. You've got to know your language. This is a language class. I work for the world language, I work in the world language department. Okay? You can take French, Spanish, Arabic, Italian, Russian, or chemistry. Okay. So, now, because you guys are like completely schizophrenic, you go from a class who is like suffering from massive brain trauma to a class that I just can't keep down and you guys are just inhaling the stuff. Let's do stock. We've already kind of done stock, haven't we? So let's do it again for the viewers at home, okay? Who are actually going to be you. Okay, so. Now let me show you how easy this can be, correct? Let me show you how easy this can be. Now, the rules that you use for binary, ternary, and stock are essentially all the same. It's really one giant, like the book treats this as one type of nomenclature. I break it up. They essentially treat it as one kind of nomenclature. Correct? You get that? Let's move this over a little bit. Okay? Let me say that again. They treat these as one kind of nomenclature because it's really all the same. Correct? Now, we've done binary and we've done ternary. And my type of binary and ternary is simply that this binary and ternary means that everything has a known oxidation state. If I say to you sodium phosphate, right? +1, -3, Na3, PO4, right? Okay. Easy, 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 right? Okay. But what happens if I say what's that? Writing the formula is easy, isn't it? What's the formula? This is cobalt. What's the formula? True or false? Yes or no? Yes. This is stock system now, right? Because cobalt can have several different oxidation states, correct? Yes or no? Yes? Okay. So, is that the formula, right? Now, what's the name of that? If you have a transition element, how do you name it? Remember? You take a Roman numeral. This is the cation. Now, the cations are named strangely in stock system. Listen carefully. When the cation is a transition metal, when the cation is a transition metal, and you're naming the chemical formula, you write the name of the cation.
Low battery.
Low battery already?
Yeah.
You write the name of the cation. You write the name of the cation with its oxidation state as a Roman numeral following the name of the cation. Does that make sense? Remember, iron 3, oxide. Right? Is that good? Is that charging? Yes. Okay. So let me say that again. When using in a formula a transition metal cation, a cation that is a transition metal, and you write it in the formula. Here's the formula. Okay? And you're writing the name. This is a formula. I want to write the name. You write the name of the cation, cobalt, followed by a Roman numeral pronounced as a number, and then the name of the anion. Write that down. So this is going to be cobalt cobalt 3 phosphate. That's how you say that. cobalt 3 phosphate. That's how you say that. All right? Let me go through this again, and you can take this down. You ready? This is a chemical name. This is a chemical formula, correct? When you write a chemical formula, and that chemical formula includes a transition metal, which is the cation, correct? When you write a formula, and the cation on the left, is a transition metal, and you want to write the name of the formula. You write the name of the cation, followed by the Roman numeral, which is the oxidation state. Then you write the name of the anion, according to rules from binary and ternary nomenclature. And then when you say the name, it's the name of the cation, cobalt. You say the number, Roman numeral number, 3, and then you say the name of the anion. Is that clear? Am I making this sound almost silly? How many people who learn a language find that after a while it's kind of silly? You have to learn how to count in the language. Isn't that pretty basic? Right? Well, that's what we're doing. We're learning how to count and just recognize numbers, essentially, yes? Okay? So, cobalt 3 phosphate. Yes? All right. Let's do this. You tell me, I'm going to write a chemical name on the board. If you're given a chemical formula, you have to give me the chemical name. Okay? I'm going to put a chemical formula on the name, and I'm going to put a chemical name on the board. Chemical formula and chemical name. If I give you a formula, you give me the name. If I give you a name, you give me the formula. That's all you have to do. That's it. Clear? Shall we try that? Okay? All right. So, let's do this. You ready? Okay. Okay, look back at your notes as to what sulfate is, right? So I want to know the formula. Okay? Now here I'm going to give you a formula and you give me the name, okay? Yes? All right, let's do, I don't know, let's go crazy. Okay? So I want to know the name of this. You put that here. You take this formula and you put it here. Okay? When I give you a quiz, you're essentially going to have to do this. This is your quiz. This is a practice quiz. I give you a chemical name, you have to write the chemical formula. I give you a chemical formula, you have to write a chemical name. Easy? Easy peasy, lemon squeezy, baby. Easy. Right? Yes? Okay? I'm not asking you to take a quiz now, but pretty straightforward, or what? Tons and tons and tons and tons of resource material on YouTube on my site. What do we got? Anybody got this done yet? Yes? CR what? CrSO4. That's not done yet. What's the charge of the chromium and what's the charge of the sulfate? So what do I put? CR what? CR, what do I put here? What do I put here? What do I do? Come on guys, you got to give me the whole formula. I have to have a neutral particle. See, in other words, this looks like this. Right? I need a neutral particle over there. What's my neutral particle? That's what you gave me, essentially. I know that Cr is chromium. You can look at a periodic table. I know that sulfate is SO4. I gave you that. But what's the formula? Cr what? Cr2 parentheses. I like it. Yeah! Excellent. Like it. What do we got? What's the name of that? What's the name of that? What's Mn? Can you pronounce it? It sounds like you got a bug in your throat. Not magnesium, like you got some phlegm coming up. Manganese. 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 Manganese, I'll help you. What's O?
Oxide.
There you go. Oxide. Did you say oxide? Excellent. Oxide. Manganese oxide, right? Not magnesium, manganese. Like you're trying to you got some phlegm up there going, all right? So manganese what? Isn't true or false? Manganese is a transition element. Yes, it is.
Yes.
So you need a Roman numeral. Excelente. Can you work backwards? Can you add, subtract, multiply, and divide, and count? Can you? What is the charge of that manganese? Well, what's the charge of each oxygen in MnO2? What is the charge of each oxygen in MnO2? What's the charge of each oxygen in MnO2? What's the charge of each of oxygen? Come on, guys. 2, right? So what would 2 oxygens be? What's the charge of total charge on the oxygen? What's the total charge? This is -2. How many 2's do you have? How many oxygens do you have there? How many oxygens do you have there? You have 2. All right? I know this is like advanced math, but what is -2 and another -2?
Yes, -4.
You're guessing? I hope you're not guessing. If each oxygen, if this is -2 and this is -2, together I'd have minus what?
4.
You've got to guess? Is that what you're doing? Is that what you get? Is that what you're taking? Is that what you're telling me? You're guessing?
Yeah, I'm guessing.
Okay, good. Excellent. Do you understand? It's -4, right? -4. Right? Now, what's the rule? This is a neutral particle, isn't it? Isn't this a neutral particle? Therefore, the right equals the left. Listen carefully. And this is true for all nomenclature. The total anion charge, write this down. For all chemical formulas, the total anion charge must equal the total cation charge. Do you get that? So if what's the total anion charge here for the oxygen side? -4, right? So what's going to be the total cation charge? +4. Now, call me crazy, people have, but if the total charge is +4 and there's only one manganese there, what would be the charge of each manganese that's contributing to that +4? Say it. Say it. Look, if this marker has a charge of +10, and there's only one marker there, what would the charge of this one marker be? +10, right? If I have 3 markers, and they all have a charge of +30, what would the charge of one marker be? +10. If the total charge here is +4, and there's only one manganese there, what would the charge of each manganese be? +4. What Roman numeral are you going to use to represent the 4?
IV.
IV. You get it? This is called manganese 4 oxide. Do you know what the common name of this is? You want me to really confuse you? In the book, they go over classical names. That's a really polite way of saying common names. Classical names versus common names. Yes? No, sorry. Common names, common and classical names versus IUPAC. This is IUPAC. Ancient International Union of Pure and Applied Chemistry, right? One of the common names, like, I'm going to go off camera for a second. I have right here. Oh, it's not named that. Go figure. It's named IUPAC. Here I have, can you see that? Does that come up? Can you read that as I'm shaking it? Does it come up? Can you see that? Manganese 4 oxide. Okay, manganese 4 oxide. I automatically assumed that was going to come up as the old name. What the name I go by? I can write. The way, when I grew up, you know, I name it the common name. Not that I'm terribly old. Depending on your point of view, I guess. I'm young or old, depending. But we would call it, books would call it, manganese dioxide. That's what we would call it. But we don't call it manganese dioxide. Stock system. Pretty straightforward? Yeah? Yeah, pretty straightforward. Now, I'm going to give everybody 5 points extra credit. Can you imagine? Everyone's going to be so jealous. Because I'm going to do Greek system. And you're saying to yourself, you've got to be kidding. You're doing Greek system? What kind of crazy person are you? Well, you know what I'm going to do? I'm going to do Greek system, and you're going to say to me, that's it? That's the whole system? That's it? That's the easiest of all. The Greek system is the easiest system. The Greek system, by and large, is used for very specific substances. And the reason I'm doing this system now is because we're going to be starting bonding. Okay? When you have two nonmetals, they generally bond covalently. Okay? For instance, carbon dioxide, carbon monoxide. Right? You see that? Okay? This is the Greek system. Are you ready? It's right in your book. It's very easy. What are the Greek prefixes? What do we use? What are our Greek prefixes? You ready? What's one? Anybody know? Mono. Di. It's right in your book. Mono is one. Di. Tri. Tetra. What's five? Penta. Hexa. Hexa. Hepta. H-E-P-T-A. Hepta. Octa. Nona. What is it? You can go. Just don't ask me. Just go if you got to go. Octa. Nona. And Deca. Okay? You got it? Guys, I want focus, refocus, guys. Come on. Mono, di, tri, tetra, penta, hexa, hepta, octa. Right? You've heard of octane? All right, every dash is a bond. Every dash here means that it's attached to a hydrogen, right? You've ever heard of octane? That's octane. 8 carbons. 8 carbons. Only hydrogen and carbon. It's a hydrocarbon. Okay? Just trying to clue you in to the fact that you've used Greek prefixes before. Okay? So what's the Greek prefix? Now this is the only rule. You ready? The number of elements that are there, you use that prefix. If there's 2 elements there, it's di. Dioxide. Dichloride. Dinitride. Easy? Yeah. Yes or no? Yes? Okay. This is the only caveat. If there's one positive component, you don't use mono. Mono is used for one element, but only as an anion, not for the cation. I know, go figure. All right? So what's the name of this? What's that?
Carbon dioxide.
Yes, you have to think about it. Yes, exactly. Carbon dioxide. That's carbon dioxide. What's this? What's that? CO. Carbon monoxide. You see how you're using mono for the negative? Yeah? So let's name these. What's this? Acid rain. This plus water. What's that called? Sulfur dioxide, right? What's this? Dipentoxide. Yes? Dinitrogen pentoxide. Yes? What's this? Tetraphosphorus deck oxide. Easy? That's it. That hard? That's it. That's the Greek prefix system. Is that easy or what? Yes?
We have like 22 in oxygen. How can
You don't. Don't worry about it. Just say, Mr. Darcy, how do I do this? Just don't worry about it. I will never give you a problem where you use a prefix greater than 10. Okay? Understood? Okay. Everybody get it? Easy? Isn't that the easiest one? And when do you use this? When do you use this? To what? To non-metals. That's when you use it. Yes? That's it. So we've done binary, ternary, stock, and Greek. Acid's very easy. I mean, it's really easy. But again, it's a lot. But I'm telling you, you will be way ahead of the curve if you start on those videos. Okay, there's 5 minutes left. If you want to hand in some homework early, I'll take that down now. We're off.